Hi and Assalamualaikum to all the panelists. My name is Tengku Muhammad Ashraf bin Halim. I am from Faculty of Manufacturing Engineering, University Technical Malaysia Melaka. My supervisor is Prof. Madia. I am Dr. Muhammad Azli bin Abu Bakar. I am from Process Cluster. My title is Heat Treatment Analysis of 22 MNB5 Boron Steel for Refractory Application. For the introduction, I will explain a little bit about the boron steel. In the new era of automotive industry, boron steel is highly recommended, designing car of lower weight and keeping height safety. This study based on the effect of alternatizing temperature of holding time on the mechanical properties of hot stamping boron steel, a series of quenching process, tensile strength and hardness of boron steel sample are measured. The result of this study is to achieve a high-strength boron steel material, whether the automotive industry or some other related areas, such as cutting instrument or machining application. So the figure is the chassis about the car. The boron steel is mostly be assembled at the side of the car and the front of the car. The problem statement of my PSM, the first one is the current heat treatment of boron steel wastes a lot of energy as the large furnace is used. It also important to handle a small specimen. The second one is if the heat treatment is conducted, the operator can be seriously injured due to the hot state of furnace is released to the environment as the user open the door of the furnace. The third one is nowadays furnace is only suitable for large component as the energy required to work, but the thermal treatment is the same as the small or large part. I have three objectives for my study. The first one is to conduct quenching on boron steel using resistant heating furnace. The second one is to analyze the hardness of boron steel during the heat treatment process is being held. And the third one is to analyze the microstructure of the boron steel during the heat treatment process is being held. The literature review, I have done some study about another journal related to my PSM. For the material boron steel 22 mmB5, the Gracia Escosa says boron steel is typical used in the hot stamping process. Next, the microstructure of treated 22 mmB5 also influence the material physical properties, say by the fan. According to Gracia Escosa 2017, the tensile strength increased from 600 MPa to 1500 MPa in a standard hot stamping process at 950 degrees Celsius, 5-minute process length, and a quench in a closed water cool die. For the annealing process, based on the journey by the Tuong in 2018, the annealing process is regarded as a standard hardening process. The method can harden various types of metal and also composite. Khan, Zulfikar and Hussein also say that one of the annealing effect on the material is the size of the grain in the material. I'm also do the literature review on the normalizing. The microstructure of a material that has been undergone the process of normalization, it has increased the size or residual austenity and a packet grain by Fukumoto et al. Referring to Zhu et al. 2018, the analysis of the 1045 steel microstructure and tensile properties with NBTIC, the normalizing process has proven that the significantly improve the material mechanical properties. For the hot press quenching, according to Nishibata and Kojima, the hot stamping process is commonly used in the manufacture of automobile parts in the current automotive industry. The water will force the cooling effect faster than the die quenching, thus reduce the hardening time. It says by the Manio, Mori and Fujimoto 2015. For the resistivity sintering, journal by the Bezos and Sklavo 2019 says that the sintering is unlike the other hardening process using the heating element. The key feature of the method is use electricity. Groza on 2000 says that the advantage of sintering process is allowing the high density metal to sinter in the short period. For the methodology, I will explain a little bit about my flowchart on process for my PSM. The first one, I will choose the raw material, which is boron steel 22 mmB5. Then I will perform heat treatment using resistive sintering, which is I will go for the duration of heating process and the emission capability. Then I will perform quenching in different medium such as oil, water, and ice. Then I will analyze the treated specimen parameter using the hardness test and the microstructure test. For the next slide, I will explain a little bit about the machine and the part that I will use for my methodology. First one is the laser cutting machine. I will use the laser cutting machine to cut the boron steel sheet into desired cutting tool shape. The second one is boron steel itself. The picture, as you can see, is the boron steel after cut by the laser cutting machine. That's just an example. All the dimension determined by the vernier caliper, which is 1.76 mm and 11.87 mm. And then I will do the heating for my specimen using the resistive sintering machine. This is the new machine innovation to substitute of conventional hot pressing machine with furnace. This also the 4 machine that I will be used for my experiment result. The first one is rotating polishing machine, which is to be used to polish process in the pre-processing to be formed. This is very important to use rotating polishing because we need to get the clear surface before do the optical microscope. I use the silicon carbide sandpaper with a roughness of 300 micron, 600 micron, and 800 micron. Next, micro hardness tester. Micro hardness tester is a hardness test to perform by the micro hardness tester. HV scale use the test machine to determine the hardness of the material. Total load of 0.2 kg applied to the specimen to determine the highest hardness of material can withstand. The next one is I use the Flux TI400, which is the thermal image camera. This product can generate the heat analysis by using thermography camera. The last one is optical microscope. I will use this microscope to see the microstructure test performed with magnify level at 20. This one is easy to operate microscope in order to see the microstructure of specimen. I can see it more easily than use my bare eyes. That's all for my presentation of this PSM1. I hope you understand. Thank you and stay safe.